Alright, hello everyone. I hope everyone is doing well and is progressing through the course. Finished up your third projects working with AWS. We're going to be shifting gears now and jumping into Spark, which is kind of a key component in today's age of big data. There's many other technologies. One of the originals was Hadoop, but Spark has proven to be the on the forefront of this new age of big data. So we will be using PySpark, which is a Python API which allows us to work with Spark. I hope you guys have gotten through some of the introductory videos into this new chapter of the course. And what I'm going to be going over today is how we can actually um, use our Jupyter notebooks to pull data from our resilient distributed dataset architectures and kind of just display the similarities between it and pandas. So I hope that you guys are familiar with pandas now that we've been using it throughout the course. So let's go ahead and dive in now. So up here I just have my imports. First we're going to be creating our entry points to Spark. So I do a try accept, try sc.stopped, and then we accept and pass if that works out. And then we just say from PySpark import Spark context and Spark conf. From PySpark.sql import Spark session. We're going to say sc equals Spark context, Spark equals Spark session. Spark context equals Spark context, which we had defined up here. Okay, so the resilient distributed dataset architecture. So the way it works is we feed a file, and what it does is it distributes it in chunks, very similar to how Redshift works with our clusters. It wants to arrange the data in such a way that when it is going to be fed to our CPU via memory, it will do so in the most optimized way possible. What it also has is replication for fault tolerance. So the driver down here manages the file system namespace. And let's see here, I don't know why my notebook got all messed up, but alright, so the class PySpark.SparkContext, it creates a client which connects to a Spark cluster. The client can be used to create a resilient distributed dataset architecture object. And there are two methods from this class for directly creating RDD objects: parallelize and text file. So first we're going to be going over parallelize. Parallelize distributes a local Python collection to form an RDD. Common built-in Python collections including dist, list, it's supposed to be dict, list, tuple, or set. So here's just a few examples how this works. So we define RDD, and using the parallelize method, we are feeding it a list. Then we call the collect method, and that will return our object. So we can also feed it a tuple. In our case, we have a tuple containing the words cat, dog, and fish. And using the sc.parallelize, we call the method, feeding it our tuple, calling rdd.collect, and we can see now that our values contained in the tuple have been collected. So here we're providing a list that contains two different tuples. If you notice, they do have different sizes. We have one with cat, dog, and fish, and the other with orange and apple. So once again, we just call sc.parallelize, we provide our list of tuples, and when we call rdd.collect, you can see in fact that our data was loaded. And this is an example from a set. So just a refresher, a Python set, though it uses the curly braces similar to a dictionary, a set only contains unique values. So as you can see here, we have dog and cat are both repeated multiple times, but when we run our parallelize and our collect, you can see only the words fish, dog, and cat have been collected. So one thing to note here, when we're using only a dictionary, only the keys are going to be loaded in. Alright, so text files. The text file function reads a text file and returns it as an RDD of strings. Usually you will need to apply some map functions to transform each element of the RDD to some data structure/type that is suitable for data analysis. When using the text file method, each line of the text file becomes an element in the resulting RDD. Alright, so let's see what we mean by this. So I'm using some sample data that I have on my local system here of car information. So we call sc.textfile. We provide the path to the text file, in our case the CSV. And when we call .take5, we see what's returned is the first 5 lines from that CSV file. So the .take is very similar to the pandas .head, where you only want to return a certain amount of value. So let's see if we change that to rdd.take10. As you can see, we are returning the first 10 lines in our text file. So it's treating each line as an individual entry. Alright, so when we call, once again, we're doing this on a text file this time. We can see that each line broken up by a new line entry becomes a single data point in our RDD. So now I'm going to jump over here. We have another one. So now we're going to talk about the data frame object. So let me go ahead and close this just so we don't get any confusion of mixed up variables. It's bad practice to have multiple Jupyter notebooks open at the same time. So let's go ahead and we'll connect to PySpark using our Spark session and the Spark context module. Alright, so we're going to create a data frame by reading the file. Alright, so how we do that is we use very similar once again to pandas, the spark.read.csv. We provide the path to the CSV. We have a comma separated value, CSV file. So our separator is going to be a comma. We provide the encoding. We're just going to be using UTF-8 in this case. We say comment equals none. We don't want any comment in the file. We do have a header, so we define header equals true. And infer schema equals true just kind of does some automatic formatting of our data frame object. Alright, so let's run that. We have defined our variable empty cars, and then we call emptycars.show. We provide n equals 5, n being the amount of rows in the data set that we want to return. So each line in that CSV file is currently being read in as an individual object, and Spark is formatting it in such a way that it becomes a data frame very similar to Pandas data frame. And it gives us this nice little ASCII character display here. Alright, so to create a new data frame, we use the create data frame function. Alright, so from an RDD, elements in the RDD has to be a row object. In order to do that, we're going to import from PySpark.sql import row. Now what we do is we can convert data into a row by calling sc.parallelize. We use that row function and we provide it two different variables, an x and a y. So we're providing two different rows, the first one being 1, 2, 3 with A, B, C, 4, 5, 6, and then with E, F, G. So the X is the column name, the Y is the second column name, and what we're doing is we're passing arrays or lists of 3 characters for each row of this new data frame. So we call it spark.createDataFrame, all camel case. Oops. Forgot to run that. And when we call df.show, we should get our data frame returned. Okay, so from a data frame, so we import pandas. We say PDF equals pd.dataframe. We define a data frame just as we did up here. We have our first column being X. We're going to provide it 1, 2, 3. And we're going to provide a second row of 4, 5, 6. We're going to have a column Y that also contains 2 different rows, one being ABC and the second being EFG. So as you can see, we are getting very similar results from and pandas. They're both creating data frame objects. The only difference within pandas is that we have this index here. But we can also just directly feed that pandas data frame directly into Spark and calling the create data frame function, and we'll get our the exact data frame returned. Alright, so from a list, each element in the list becomes a row in the data frame. So here we have a list of lists, the first one being A and 1, and the second being B and 2. So remember, it says that each list will become a row in the data frame. So when we call df equals spark.createDataFrame, we provide it my list, and as a second argument, we provide a list, and that will contain the column names. So the pandas way of doing that would have been pd.dataframe, you provide the data, and then you would have said columns equal letter and number. So it's very similar. I think that actually you don't even need to define columns. I think that it automatically does expect the second argument to be the column names, though it is not necessary. So I hope that everyone is kind of starting to realize, hey, this isn't going to be that challenging. This is all very similar to what we've already been doing within pandas, at least for now. Alright, so when we run that, we provide the list, we provide the column names, and when we call df.show, it returns the data frame. Alright, so let's check out these data types here. So when we call the df.datatypes, it returns the column, and then it says the type of data type that it contains. In that case, it's a string. For number, we have big int, and there also is small int as well, but it defaults to big int. Alright, so my list, we're providing the two different lists contained in it. We're going to create our data frame providing my list. And then if we only were to provide one column name, then it automatically defaults, very similar to pandas, and it would just provide that _2 as a default column name. And once again, if we were to call it df.datatypes, we see my column is a string, and our second column, _2, is a big int. So the following code below will generate a data frame consisting of 2 columns. Each column is a vector column. So why vector columns are generated in this case? In this case, the list, my list, only has one element, a tuple. Therefore, the data frame has only one row. This tuple has 2 elements, therefore it generates a 2 columns data frame. Each element in the tuple is a list, so the resulting columns are vector columns. So up here we provided 2 lists. 2 independent lists resulted in 2 rows, but here we're only providing a tuple that it itself contains 2 lists. So when we run that, what is returned is a data frame with 2 columns x and y. The x column receiving the first item of the tuple, being the list A1, and y receiving the second item of the tuple, being the list B2. Alright, so we're going to go over a little bit more here. A column instance can be created in 2 different ways. We can directly select a column out of a data frame using df.callName. You will see that there's much use of camel case here. Obviously, someone has some Java background when creating PySpark. So if you guys are very used to pandas or Python by now, you will notice that it's not really a convention, but you will be using camel case quite a lot while using the PySpark library. Alright, so that said, we're going to be, to get a column out of a data frame, we call it df.callName. To create from a column expression, we say df.callName plus 1. Technically, there's only one way to create a column instance. Column expressions start from a column instance. So remember how to create column instances, because this is usually the starting point if we want to operate data frame columns. The column classes come with some methods that can operate on a column instance. However, almost all functions from the PySpark.sql.functions module take one or more column instances as arguments. These functions are important for data manipulation tools. So some of these methods I've provided below. Methods that take column names as arguments is core, so correlation, column 1 and col 2. We have cov or covariance, column 1, column 2. Crosstab, column 1, column 2, obviously 2 arguments, and then describe. So calls refers to only the column names as strings. And then methods that take column names or column expressions, or both as arguments. So we have cube, we have drop, we have a group by, roll up, select, we have a sort module, sort within partitions, we have an order by, sample by, 2df, with column renamed, and filter. those are just to name a few, some of the more common ones that we will be using in the course. So I highly recommend that you look up the documentation on PySpark, and then we just go through it, read it. You're not going to be able to remember every single one that exists, but I found that it is incredibly helpful just to kind of read through documentation. Once you read over it, if you see something that stands out, it will stick in your mind, and when that time comes that you need it in your work, all it takes is a simple Google search, and you'll be able to see exactly how to implement that, what arguments it takes, and so on. Alright, so now we're going to go over conversion between RDDs and data frames. So once again, we're going to connect to our Spark session. And once again, we're going to be using the car data. Alright, so in order to convert a data frame to an RDD, we use the pyspark.sql.dataframe.rdd function. Each element in the returned RDD is a pyspark.sql.row object, and a row is a list of key value pairs. So for example, when we call mtcars.rdd.take2, we can see what's returned is 2 rows of our data. We have CO being column 0 is the model of the car. We have miles per gallon, the cylinders, the dispersion, horsepower, and so on. If we were to call .take4, you can see that now 4 rows have been returned. So with an RDD object, we can apply a set of mapping functions such as map, map values, flat map values, and a lot of other methods that come from RDD. So here we're going to call the map function, and we're going to provide a lambda function, which is an inline function in Python. So what it does is you say lambda x, and for that x, this is what we want to return. So it just basically shortens the, instead of writing define my function that takes x and then return, x C0 and x miles per gallon, the lambda function just shortens that that function definition. So it's lambda x colon, and then you provide what you want to do with x. So the return is implied. So when we run that, we say mtcars map.take5. All that's being returned is our first column, which was the name of the car, and then the miles per gallon. So here we're going to do the map values method. Map values also takes a function. In our case, we're going to provide a lambda, and then we're going to say for our variable x, we want to return x, and then x times 10. So what's returned is going to be the name of our cars, because we're working on the mtcars map that we defined up here. So we already have the name of our car here. So what we're returning is the first value, x, which is the name of the car, and then we're going to return x times 10. When we run that, it's returning the miles per gallon multiplied by 10 as a second item of that list. So to convert the RDD to a data frame, we use Spark session.createDataFrame function. And every element in the RDD has to be a row object once again. Alright, Alright, so we're going to load our text file here. And then we're going to save the first row to a variable. So we're going to say RDD raw dot map. We're going to provide a lambda function. We're going to say x.split on the commas because the rows are separated by the commas up here. And then we're going to say filter, provide a lambda, and for lambda x, x1 miles per gallon being our first, I'm sorry, this first index of our text file. So x1 equals mpg, and then we're going to collect the very first one. When we call header 0 equals model, we then have renamed our first column underscore CO. We have now named it model. By using square bracket notation, we are very easily able to rename the name of it. So we're going to save the rest to a new RDD. We say RDD equals RDD raw, which was our text file up here that we defined. RDD raw.map, providing our lambda function. We're going to split on the comma. And this time we're going to access everything that's not equal to MPG. So this time we're going to take the first two rows, and what is returned is our rows minus the column for miles per gallon. So to convert RDD elements to RDD row objects, first we define a function which takes a list of column names and a list of values. We create a row of key value pairs. So since keys in a row object are variable names, we can't simply pass a dictionary to the row function. We can think of a dictionary as an argument list and use the star to unpack the argument list. So what we're doing here is we're going to call from PySpark.sql import a row. Define my dict is a dict of the zipped objects. So we're providing the first argument will be a list ABC, and the second list will be range 1 through 4. And then when we unpack those, we are now getting a row. So column A equals 1, which was the value of this range object. Second column B gets assigned 2. Third column C gets assigned 3. Alright, so we're going to define a function here, list to row. So we define list to row. We're going to provide the keys and the values. We say row dict equals a dictionary, and we're going to zip the keys and the values, and then we're going to return a row unpacking the row dict. So now that we've defined this list to row function, we can say rdd.map, provide lambda x, and then within the lambda, we're going to call our list to row function, providing its arguments, which in our case will be our header and x. And when we call our rows.take, we can see that in fact the dictionary was unpacked, and we now have our RDD objects, 3 different rows, all containing the information that we want. So one thing to note here is that Originally, we had model and MPG as the first columns, but because dictionaries do not guarantee sorted information, though that is now a capability within Python, in this case, in order to return the information in the most optimized manner, in this instance, it resorted the values, which does not matter though, because all that matters is that we have our key and our value here. So now that we have our RDD object, we can convert it to a data frame. And if you remember how to do that, we just call spark.createDataFrame, and we provided the RDD rows which we just defined. And when we run that, we are returned our Spark data frame. And as I mentioned, we have our model and our MPG now stored in the middle of the data frame rather than being the first column. So that is one thing to keep in mind if you do use this method, that dictionaries do not guarantee order. Alright, and finally, I'm going to go over merge and split columns. So once again, connecting to our Spark session, providing the Spark context. And then, so sometimes we need to merge multiple columns in a data frame into one column, or split a column into multiple columns. We can easily achieve this by converting a data frame to an RDD, applying our map functions to manipulate the elements, and then converting the RDD back to the data frame. So we're going to read our CSV. We're still working on our car data. We provide the separation, which is going to be our comma, using UTF-8 encoding. Comment equals none. And we say header equals true, which will be our columns. So just to make sure that everything loaded properly, we can call mtcars.show n equals 5, n being the amount of rows that we want to have returned. So we adjust the first column name. So as I mentioned before, we can use square bracket notation to automatically reassign values. So you can see here that we have the first column being underscore C0, which is just kind of a default name. So we say column names equals mtcars.columns, which returns a list of the items which define our column names. And very easily we can change that generic column name for our models by saying call names square bracket 0 index 0 equals model. Then we want to add it to our RDD by saying mtcars equals mtcars.rdd.2df, and we provide the column names. And now when we run it, we can see that in fact our first column for our models has been renamed to model. Okay, so now to merge multiple columns. We convert the data frame to RDD, then apply our map function to merge values and convert elements to row objects. In order to do so, we're going to have to import row once again from PySpark.sql, mtcars.r_rdd equals mtcars.rdd. We call our map method, providing to it a lambda. We say for our variable x, we want to say row model equals x0, values equal x1 and forward. So what the 1 and forward is doing is it's collecting all of these separate columns that come after the very first index, index 0, and it groups them all together into a tuple. So 21 is our miles per gallon, 6 is our cylinders, 160 is our dispersion, and so on. Is it dispersion or displacement? Sorry, I've been saying dispersion this whole time. Obviously, I'm not a car guy, but I'm pretty sure that it's displacement. Alright, so moving on, now that I've embarrassed myself. So we can create a new data frame from the obtained RDD. We do so by calling spark.createDataFrame. We provide our empty cars, RDD, and then we can call .show and return the first 5 rows of our data frame. So in this case, now we only have 2 columns though, our first being our model, and then we have the associated values all contained within their own list. So we have an array for each value of this values column. So in order to split one column, we use the above data frame as our example data, but again we need to convert the data frame to an RDD to achieve our goal. So to convert the RDD back to a data frame, we simply say empty cars RDD2 equals emptycars.df.rdd.map. We provide the lambda. So then we use that row from our PySpark.SQL. Turning it into a row, we say the model equals x0. We say x1. In this case, we're just going to use the first index up to the 5th. I'm sorry, up to the 4th, not including the 5th. And then we're going to have a third column, x2, which is going to be the first index of x. And then we're going to provide the values from the 5th index on. Then we call spark.createDataFrame, providing the empty cars RDD2, which we had just defined. And what's returned here, as you can see, is a data frame now where we have our values grouped up into these individual columns. So we now have 3 columns, model, x1, and x2. x1 containing these values up here, which was the 1 up to 4th. I'm sorry, it's going to be, 1 through 4, and then index 5 and onward were placed in x2. Alright guys, so that wraps it up for this introduction tutorial into some basic PySpark. I hope that you guys are feeling pretty comfortable with this. It's really not too different from working with pandas. I found that it was a pretty easy transition for myself when I first got into it, just because I had already worked so much in pandas, and this concept of data frames and group bys and so on are, familiar topics. So the one thing that you do have to kind of focus on is just this, the rdd.map, and then you provide the lambda. It's a functional approach because Spark was written in Scala, so many of those principles have been carried on into the Python version. There is reasoning behind it, and I hope that you guys have found this useful. I will go ahead and try and share these notebooks with you in case you want to go over them yourself, and I recommend just kind of practicing with these very basic commands and getting used to converting your RDD objects into data frames. And feel free to reach out if you have any questions, and I will be sure to get back to you. Alright guys, take care.